Several factors can contribute to monitor flickering even after implementing shielding. Electrical interference stemming from loose connections or faulty wiring within the electrical system can induce fluctuations in the power supply, subsequently causing monitor flickering. It is crucial to meticulously inspect all electrical connections, ensuring they are securely fastened. Furthermore, electromagnetic interference, or ME, despite the application of shielding, might still penetrate and affect the monitors. In such instances, exploring the implementation of additional shielding or isolating the monitors from the EMI source is advisable. An inappropriate monitor refresh rate, specifically if set too low, can manifest as flickering. Verifying that the monitors are configured to an adequate refresh rate, such as 60 Hz or higher, is essential. Outdated or problematic graphics card drivers can instigate display anomalies, encompassing flickering. Therefore, updating the graphics card drivers and investigating any hardware-related concerns with the card is recommended. Software conflicts arising from specific software programs or settings may impinge upon monitor performance. Attempting to disable recently installed software or adjusting graphics-related settings might alleviate the issue. A faulty or insufficient monitor power supply can precipitate flickering. Ensuring that the monitors employ appropriate power adapters and cords is imperative. Excessive heat buildup can trigger component malfunctions, which may manifest as screen flickering. Assessing the ventilation surrounding the monitors and ensuring they are not overheating is crucial. To troubleshoot monitor flickering, firstly, isolate the issue by disconnecting the monitors from the network room equipment and establishing them in a distinct location. If the flickering remains, the issue likely resides outside the network room. Secondly, scrutinize electrical connections by examining all power cords, outlets, and surge protectors, ensuring that the monitors are correctly grounded. Thirdly, inspect monitor settings by verifying that the refresh rate and other display settings align with the recommended parameters. Fourthly, update graphics drivers by installing the latest drivers available for the graphics card. Fifthly, isolate software conflicts by deactivating any recently installed software and observing whether the flickering diminishes. Sixthly, replace monitor power supplies. If the monitors utilize external power supplies, attempt to substitute them with known good ones. Seventhly, check monitor ventilation by ensuring adequate ventilation and preventing overheating. Eighthly, consider supplementary shielding if the initially installed shielding proves insufficient, contemplating the addition of magnetic or electromagnetic shielding to further mitigate EMI. If the flickering persists despite adhering to these measures, consulting with a qualified technician for comprehensive diagnosis and repair is advisable. The unit of measurement for frequency, Hertz, abbreviated as HE, signifies the number of cycles per second of a periodic phenomenon. In the context of monitor refresh rates, a higher Hertz value translates to a more frequent updating of the screen image, resulting in a smoother visual experience and reduced flickering. Conversely, a lower Hertz value may lead to noticeable flickering, particularly for users sensitive to such effects. Graphics cards, also known as video cards, are essential components in computer systems responsible for rendering images, videos, and other visual content on the display screen. They play a critical role in determining the visual performance and capabilities of a computer, particularly in graphics-intensive applications such as gaming, video editing, and 3D modeling. Graphics cards consist of several key components, including a graphics processing unit, commonly abbreviated as GPU, which serves as the main processing unit responsible for performing complex calculations and rendering tasks. The GPU is designed to handle parallel processing, making it highly efficient at processing visual data. Graphics cards also include memory, referred to as video memory, or VRAM, which stores textures, frame buffers, and other data required for rendering. The amount and speed of VRAM can significantly impact the performance of the graphics card, especially in high-resolution or graphically demanding applications. Graphics card drivers are software programs that enable the operating system and applications to communicate with the graphics card. These drivers provide instructions and optimizations that allow the graphics card to function correctly and deliver optimal performance. Regularly updating graphics card drivers is essential to ensure compatibility with the latest software, resolve bugs, and improve performance. Software conflicts can arise when different software programs installed on a computer system interfere with each other's operation, leading to unexpected behavior, errors, or instability. These conflicts can occur for various reasons, such as incompatible software versions, conflicting system settings, or resource contention. Identifying and resolving software conflicts can be a challenging task, as they may manifest in subtle or unpredictable ways. Troubleshooting software conflicts typically involves isolating the conflicting programs and adjusting the settings or dependencies to eliminate the interference. Power supplies are essential components in electronic devices that provide the necessary electrical power to operate the various internal components. They convert the alternating current, or AC, from a wall outlet into direct current, or DC, which is the type of electricity required by most electronic devices. Power supplies are designed to deliver stable and regulated power to ensure the proper functioning of the device. Power supplies come in various forms and sizes, depending on the specific requirements of the electronic device. They can be internal components integrated within the device's chassis or external adapters that plug into a wall outlet. The power supply's capacity, measured in watts, indicates the maximum amount of power it can deliver to the device. It is crucial to choose a power supply with sufficient wattage to meet the device's power demands, ensuring stable and reliable operation. Adequate ventilation is essential for maintaining the proper operating temperature of electronic devices, preventing overheating and ensuring optimal performance and longevity. Electronic components generate heat during operation, and if this heat is not dissipated effectively, it can lead to component malfunctions, reduced performance, and even permanent damage. Ventilation systems facilitate the flow of air around electronic components, allowing heat to be carried away from the device. This can be achieved through various means, such as strategically placed vents, fans, and heat sinks. Proper ventilation design takes into account the device's thermal characteristics, ambient temperature, and airflow patterns to ensure efficient heat dissipation. Shielding serves as a crucial technique employed to mitigate the effects of electromagnetic interference, abbreviated as EMI, and radio frequency interference, abbreviated as RFI, on electronic devices and systems. EMI and RFI refer to unwanted electromagnetic energy that can disrupt the proper functioning of electronic circuits, leading to signal degradation, data corruption, and other performance issues. Shielding involves enclosing electronic components or systems within conductive barriers that attenuate or reflect electromagnetic radiation, preventing it from entering or exiting the shielded area. These barriers are typically made of metal, such as copper, aluminum, or steel, and are designed to provide a continuous conductive path for induced currents, minimizing the penetration of electromagnetic fields. Troubleshooting is a systematic process of identifying and resolving problems or malfunctions in electronic devices, systems, or software. It involves a combination of observation, analysis, and experimentation to diagnose the root cause of the issue and implement corrective actions. Troubleshooting typically begins with gathering information about the problem, such as the symptoms observed, the circumstances under which the problem occurs, and any recent changes made to the system. This information helps narrow down the potential causes of the problem and guide the troubleshooting process. Isolating the problem involves identifying the specific component or subsystem that is causing the issue. This can be done by systematically testing different parts of the system, substituting known good components, or using diagnostic tools to monitor the system's behavior. Once the problem has been isolated, the next step is to identify the root cause. This may involve examining circuit diagrams, analyzing error logs, or conducting further tests to understand the underlying mechanism that is causing the problem. After identifying the root cause, the final step is to implement corrective actions to resolve the problem. This may involve repairing or replacing faulty components, adjusting system settings, or updating software. A qualified technician possesses the necessary knowledge, skills, and experience to diagnose and repair complex electronic devices and systems. They have a deep understanding of electronic principles, circuit analysis, and troubleshooting techniques, allowing them to effectively identify and resolve a wide range of technical issues. Technicians typically undergo specialized training and certification programs to acquire the necessary expertise. They stay up to date with the latest advancements in technology and maintain a strong understanding of industry standards and best practices. Magnetic fields are invisible forces created by moving electric charges, such as electric current flowing through a wire. These fields exert a force on other moving charges and magnetic materials. Magnetic fields are characterized by their strength and direction, which can be visualized using magnetic field lines. The strength of a magnetic field is measured in units of Tesla, abbreviated as T, or Gauss, abbreviated as G, where 1 Tesla is equal to 10,000 Gauss. Magnetic fields are commonly used in various applications, including electric motors, generators, transformers, and magnetic storage devices. They also play a crucial role in medical imaging techniques such as magnetic resonance imaging, abbreviated as MRI. Electrical connections are essential components in electrical and electronic circuits that provide a conductive path for electric current to flow between different components or devices. These connections must be reliable and secure to ensure proper circuit operation and prevent signal loss or intermittent failures. Electrical connections can be made using various methods, including soldering, crimping, screwing, or plugging. Soldering involves using a molten metal alloy, typically a mixture of tin and lead, to create a permanent bond between two metal surfaces. Crimping involves using a specialized tool to compress a connector onto a wire, creating a secure mechanical and electrical connection. Screwing involves using screws to fasten wires or components to terminals or connectors. Plugging involves inserting a connector into a receptacle or jack to establish a temporary electrical connection. Power cords are electrical cables that provide a means of connecting electronic devices to a power source, typically a wall outlet. These cords consist of insulated wires that carry electric current from the power source to the device. Power cords are designed to meet specific safety standards and regulations to prevent electrical shock and fire hazards. They typically include a grounding wire, which provides a path for stray currents to flow back to the power source, reducing the risk of electrical shock. Power cords are available in various lengths and configurations to accommodate different device types and applications. Outlets, also known as electrical receptacles, are devices that provide a convenient way to access electrical power from a wall or other surface. They typically consist of one or more slots or holes that accept the prongs of a power cord plug. Outlets are connected to the building's electrical wiring and provide a standardized voltage and current for powering electronic devices. Outlets are designed to meet specific safety standards and regulations to prevent electrical shock and fire hazards. They typically include a grounding terminal, which provides a path for stray currents to flow back to the power source, reducing the risk of electrical shock. Surge protectors are devices that protect electronic equipment from voltage spikes or surges in the electrical power supply. These surges can be caused by lightning strikes, power outages, or other electrical disturbances. Surge protectors work by diverting excess voltage away from the protected equipment, preventing damage to sensitive electronic components. Surge protectors typically include metal oxide varistors, abbreviated as MOV, which are electronic components that change their resistance in response to voltage fluctuations. When a voltage surge occurs, the MOV divert the excess current to ground, protecting the connected equipment. Grounding is an essential safety measure in electrical systems that provides a path for stray currents to flow back to the power source, reducing the risk of electrical shock. Grounding involves connecting the metal chassis or enclosures of electrical equipment to a grounding electrode, such as a metal rod buried in the earth or a grounding wire connected to the building's electrical system. The grounding electrode provides a low resistance path for fault currents to flow back to the power source, causing the circuit breaker or fuse to trip, disconnecting the power and preventing electrical shock. Refresh rate refers to the number of times per second that a display screen updates its image. It is measured in Hz, abbreviated as HE, and indicates how frequently the screen redraws the image. A high refresh rate results in a smoother and more fluid visual experience, reducing motion blur and eye strain. A lower refresh rate can cause noticeable flickering, particularly for users sensitive to such effects. The appropriate refresh rate for a display depends on the application and the user's preferences. For general use, a refresh rate of 60 Hz is typically sufficient. However, for gaming or other fast-paced applications, a higher refresh rate of 120 Hz or 144 Hz may be desirable. Display settings refer to the various parameters that can be adjusted to customize the appearance of a display screen. These settings include brightness, contrast, color temperature, resolution, and refresh rate. Adjusting display settings can improve the visual experience, reduce eye strain, and optimize the display for specific applications. Brightness controls the overall luminance of the screen, while contrast adjusts the difference between the brightest and darkest areas of the image. Color temperature affects the overall color cast of the screen, ranging from warm to cool. Resolution determines the number of pixels displayed on the screen, affecting the sharpness and detail of the image. Insufficient shielding can allow electromagnetic interference to penetrate electronic devices, causing various problems, including monitor flickering, data corruption, and reduced performance. Therefore, additional shielding may be necessary to minimize EMI and ensure proper device operation.